Again, I am welcoming you in Maths Department and MT1502L, practical based on MT1501, matrix algebra and coordinate geometry. We have seen practical 10 in that from given polar equation of circle in from given polar equation, first of all we have identified that that equation represents a circle or not. Then we have seen that corresponding circles center and radius, how to obtain that. And if circle and center and this radius is known, we have identified its equation. Today we are going to approach several different type of problems rather than the previously we have done. If you haven't seen a theory portion of the circles second part, then first of all go to the circle, polar equation of circle and several examples. Now, in theory, practical portion, I am starting the practicals, the second portion of our practical. So here, I am posing the first problem. Let me recall things from the theory. Let circle has diametrically extreme points x1, y1 and x2, y2 known to you, that is from Cartesian equation. So this is in Cartesian form, okay? So diametrically extreme points are this, and if you think as a figure, then this is your circle. This is a diameter. Since it is diameter, it is passing through center. And these 2 points are x1, x2, x1, y1, x2, y2. And this point is your xy. Then you think of this vector and this vector, then you know that these two vectors are actually perpendicular. So whenever they are perpendicular, you know that its dot product is 0. So how to identify this vector? That is xy minus x1, y1. So let me write it as x minus x1, y minus y1 is this vector, and another vector, this is your, so taking that dot product with x minus x2, y minus y2 is equals to 0. So if you know x1, y1, x2, y2, then from this equation, you can find out all possible x and y satisfying this equation, and that will represent a circle. Okay. On circle, we know this angle is 90 degrees. So using that identity, if you want to convert this in polar form, if this is in polar, then this is equivalent to r2 theta 2, and this is equivalent to say r1 theta 1. Then this will be equivalent to r theta. So let me write this equation in polar form. I am writing here. That is r cos theta minus r1 cos theta 1. Let me first of all expand this, so better we can relate. Okay. So here in Cartesian form, expansion is x minus x1 with x minus x2 plus y minus y1 into y minus y2 is equals to 0. So the expansion is x square minus x into x1 plus x2 plus x1 x2 plus y square minus y into y1 plus y2 plus y1 y2 is equals to 0. So this is your expansion of this equation, and finally it is looking like this. If you convert this in polar form, then this x square plus y square will be your r square minus r cos theta x1 plus x2. So that is r1 cos theta 1 plus r2 cos theta 2 plus x1 x2. Let me write here r1 r2 cos theta 1 cos theta 2. Then here y times y1 plus y2, that is minus r sin theta into r1 sin theta 1 plus r2 sin theta 2 plus here it will be r1 r2 sin theta 1 sin theta 2 is equals to 0. So this is a polar equation of circle having diametrically extreme points r1 theta 1 r2 theta 2. Similarly, if you are having 3 points, then you know that for given any 3 points, there exists a circle which is passing through that. Okay. So if this point is say r1, this is r2 theta 2, and this is r3 theta 3, then for any point here r theta, the relation is r square r cos theta r sin theta 1 r1 square r1 cos theta 1 r2 cos theta 2 1 r2 square, sorry, let me write here r1 sin theta 1 r1 sin theta 1, here it is r2 cos theta 2 r2 sin theta 2 1 and r3 square r3 cos theta 3 r3 sin theta 1. Its determinant is equals to 0. That you have seen in the theory portion. So using these two quantities today in this practical session, we will solve several examples. So our first example of today, I am continuing the previous practical, but not giving the numbers as previous. So you can continue that the previous numbers, okay? So our first example is, let a circle has diametrically extreme points given as 2, 0 and 3 pi by 2. Then find its polar equation. So this is your first problem. So if we want to solve, all you have to do is put this r1 theta 1 and r2 theta 2 in this equation, or you directly write as we know that r cos theta minus r1 cos theta 1 into r cos theta minus r2 cos theta 2 plus r sin theta minus r1 sin theta 1 multiplied with r sin theta minus r2 sin theta 2 is equals to 0. Insert values. So here we are having, this is your r1 theta 1 and this is your r2 theta 2. So your r1 is 2, so that is r cos theta minus r1 is 2 cos theta 1, cos 0 is 1 into r cos theta minus r2, that is 3 cos theta 2, cos pi by 2 is 0 plus r sine theta minus r1 sine theta 1. So r1 is 2, sine theta 1 that is 0. So sine 0 is 0 into r sine theta minus r2 that is 3 times sine theta 3 theta 2 sine theta sine pi by 2 sine pi by 2 is 1 is equals to 0. So that is r cos theta minus 2 times r cos theta plus r sine theta times r sine theta minus 3 is equals to 0. That is, this is r square cos square theta minus 2r cos theta plus this is r square sine square theta, sorry, minus 3r sine theta is equals to 0. R square cos square theta plus r square sine square theta is r square. So r square minus 2r cos theta minus 3r sine theta is equals to 0. Okay, now if you want to find out the center and radius of this, then relate this equation with r square minus 2r d cos theta plus f sine theta plus c is equals to 0. So comparing with that, you are having d is equals to 1, f is equals to 3 by 2, and c is equals to 0. Okay. So if you want to find out the center, is square root of g square plus f square comma tan inverse f by g, that is square root of g square that is 1 plus f square that is 9 by 4 tan inverse f by g that is 3 by 2, and radius is square root of g square plus f square minus c, that is g square that is 1 plus 9 by 4 minus c that is 0. Now this is your radius. Okay. You can write it as square root of 13 by 2. Okay. So we have solved the first problem. Let's go to the second problem. Here you are having the reverse process, means you are given circle and one extreme point and you are supposed to find out the another extreme point. So let me write the example, that is, let the polar equation r square minus r in bracket square root 2 plus 1 cos theta plus 1 by square root 2 sin theta plus root 2 is equals to 0 if it represents a circle and one of the extreme point is 1 0, then find its another extreme point. Okay. The question is somehow simple, but you have to deal with the situation. Let me recall the things from this previous. Here, if your equation of circle is given in Cartesian form, then x square plus y square, that is always having coefficient some constant, that is 1. X coefficient is x1 plus x2, y's coefficient is y1 plus y2, and constants are sum of x1 x2 plus y1 y2. So if you are able to find out, means if you are able to find x2 and y2, then from x coefficient that you can find out x1 and y1. Okay, so using that idea, we will solve this problem. So first of all, check that this equation represents a circle or not. So you compare given equation with general equation of circle, that is r square minus 2 r in bracket g cos theta plus f sin theta plus c is equals to 0. So from that, your g is equals to square root 2 plus 1 by 2, and your f is 1 by 2 square root 2, and c is root 2. So first of all, you have to check that g square plus f square root minus c is 0 or greater than 0 or not. Okay. So g square, that is square root 2 plus 1 square by 4 plus f square, that is 1 by 4 times 2, that is 8, minus c square, that is 2. So simplify this, so that is 2 square, that is 2 plus 2 root 2 plus 1 by 4 plus 1 by 8 minus, sorry, not c square, it is square root 2. C, okay, we want g square plus f square minus c is equals to this, and that we want to check that this is greater than or equals to 0 or not. So from this, it is 1 by 2 plus this is giving you 1 by root 2 plus 1 by 4 plus 1 by 8 minus square root 2. So square root 2, simplify this. Here, let me write this is 4 by 8 plus this is 2 by 8 plus 1 by 8 plus 1 by square root 2 minus root 2. So it is 4 plus 2, that is 6, plus 1, that is 7 by 8 plus 1 by square root 2 minus root 2. You want to check this is greater than or 0. So all I am doing is multiply this whole quantity or find out the value of this. So this is approximately 1, and this is going to be greater than 0. So it can be written as 7 by 8 plus 1 minus 2 by root 2, that is 7 by 8 minus 1 by root 2. So that is 7 root 2 minus 8 by 8 root 2. And since this root 2 is approximately 1.4, so 7 times 1.4 minus 8 by 8 root 2, and this quantity is greater than 0, you can check. Okay, so this is the circle. This equation represents circle. Okay, now all I have to do is compare this equation with the general equation that in terms of that x1, x2. So I can get that which is your x1 and x2. One of the extreme point is given, that is 1, 0. Okay. So this represents circle. Okay. Now, if I write my general equation, that is from polar form multiplied with your r1 cos theta 1's situation, this equation was my final solution in terms of you when I am r1 cos r1 r2 and cos theta 1 theta 2. In that case, this is my equation. So I am keeping that with me. I can relate this equation with that equation and find out values of r1 and r2. Sorry, r1 and from values of r1 and r2, I want to find out the value of theta 1 and theta 2. Sorry, r1 and theta 1's value is given and find out r2 and theta 2. So what is your r1? That is 1, theta 1 is 0, and we are interested in r2 and theta 2. Okay. So just put these values here. So that implies r square minus r cos theta, r1 cos theta 1. r1 is 1, theta 1 is 0, so cos 0 is 1. So that is 1 plus r2 cos theta 2 plus r1 r2 cos theta 1. Let me write r1 is 1 and cos theta 1 is also 1. So this will be r1 cos theta 1 is 1. So let me write it is r2 cos theta 2 minus r sin theta. In bracket, r1 sin theta 1, sin 0 is 0. So there is just r2 sin theta 2. Here again sin 0 is 0, so everything is going to be 0. So compare of r cos theta and r sin theta. We have, see here, it is r cos theta times 1 plus r2 cos theta 2, and here r cos theta times root 2 plus 1. So root 2 plus 1 is equals to 1 plus r2 cos theta 2 and sin theta. So that is r sin theta's coefficient is 1 by root 2. So 1 by root 2 is r2 sin theta 2. So from this, you cancel this 1 1. So if I want to find out r2, then r2 square plus cos square theta plus r2 square sin square theta is this root 2 square, that is 2, plus 1 by root 2 square, that is 1 by 2. That is 2 plus 1 by 2 is 4 plus 1, 5 by 2. And here it is r square. So your r2 is root 5 by 2. And if you want to find out theta, then tan theta 2, this by this is 1 by root 2 by root 2. 1 by root 2 by root 2, that is 1 by 2. And that implies theta 2 tan inverse 1 by 2. Okay. So we have find out the extreme point. Another extreme point is r2 theta 2, that is root pi by 2 tan inverse 1 by 2. Okay, now we are moving towards the third problem. So let 3 points in polar coordinates as 1, 0, 2 pi by 4 and 2 pi by 6. Then find the polar equation of circle passing through these 3 points if exist. Here I am writing if exist only because sometimes this point may be collinear. Okay, so if you are supposed to check that these points are collinear, then also we will proceed the same process, but the outcome will be that this point are collinear. So as you know that formula is r square r cos theta r sin theta 1 r1 square r1 cos theta 1 r1 sin theta 1 1 r2 square r2 cos theta 2 r2 sin theta 2 1 r3 square r3 cos theta 3 r3 sin theta 3 1 determinant equals to 0. So let me write here, that is r square r cos theta r sin theta 1. Here r1 square, r1 is your 1, so 1 square it is 1. r1 cos theta 1, cos 0 is 1, so r1 times 1 it is 1. r1 sin theta 1, sin 0 is 0, so here it will be 0 and this is always 1. r2 square, that is 2, so 2 square, so that is 4. r2 cos theta 2, so cos theta 2, theta 2 is pi by 4, so it is 1 by root 2. So here it is 2 times 1 by root 2, so root 2. Here again r2 sin theta 2 is 2 times 1 by root 2, 2. Here it is 1. Here it is r3 square, so r3 is 2. Cos pi by 6, so cos pi by 6 is root 3 by 2. 2 sorry 2 times root 3 by 2 r3, that is 2 sin pi by 6. So sin pi by 6 is 1 by 2 1. So we want to check that this determinant must be 0. So that implies r square r cos theta r sin theta 1 1 1 0 1 4 root 2 2 1 2 root 3 1 1. Its determinant must be 0. So now you know that finding its determinant, you have to proceed, take this and then take false determinant, but you know some of the properties of determinant, that interchanging rows will give you the same determinant. So I am going to use that, and you know that applying RRE process also affects to the determinant. Let me go directly, so better it will be there. So r square times determinant of 1 0 1 2 root 2 1 root 3 1 1 minus r cos theta times determinant of r cos theta. So it is 1 4 2 0 root 1 1 1 1. Then r sin theta is plus r sin theta determinant of 1 4 2 1 root 2 root 3 1 1 1, and finally constant is 1 times 1 4 2 1 root 2 root 3 0 root 2 1. That determinant is 0. So I am using that represents r square 1 times determinant of this, that is root 2 minus 1. Here this is 0, so no effect. So from this now plus determinant of this, that is root 2 and root 6. So root 2 minus root 6 minus r cos theta in bracket 1 times determinant of this, that is root 2 minus 1 plus, since this is 0, directly from this determinant is 4 minus 2 root 2 plus r sin theta in bracket, here it is determinant of this, that is root 2 minus root 3 minus determinant of this 4 times 1 2 times 1, so 4 minus 2, that is 2 plus 1 times determinant of this, that is 4 root 3 minus 2 root 2 minus determinant of this, for this is root 2 minus root 6 minus 4 root 3 2 root 2 is equals to 0. If it is possible to simplify, you simplify, and this is our final solution. Okay, means this is our required polar equation of circle. Let me write one more problem, that let points 0 0 1 0 and 0 pi by 2 in polar form, then find its polar equation of circle passing through these 3 points and find its center and radius. So here question is having more complexity, but solution is simple. Here you know, as previously we have done, that polar equation of circle is r square r cos theta r sin theta 1 r1 square r1 cos theta 1 r1 sin theta 1 1 r2 square r2 cos theta 1 r2 sin theta 1, sorry, r1 r2 cos theta 2 r2 sin theta 2 1 r3 square r2 cos r3 cos theta 3 r3 sin theta 3 1. Its determinant is 0. So all you have to do is insert values. Your R1 theta 1 is 0. R2 theta 2 is 1 0. R3 theta 3 is 0 pi by 2. And you can set any order. Okay, I am taking this one. So that is R square, R cos theta, R sin theta 1. R1 is 0, so everything is going to be 0. So here I am writing 0, 0, 0, 1. R2 square, R2 is 1 0. Oh, sorry. Here I have made a mistake. In equation, it is here. Okay. So here it will be 1. Now R2 square, so that is 1. R2 cos theta 2. So that is R2 is 1, cos theta 2 is cos 0 is 1. So here it is also 1. Here it is R2 sin theta 2. Sin theta 2 sin 0 is 0. So here 0, 1. R3 square. So R3 square, R3 is 1 square. R3 cos theta 3. So R3 is 1. Cos pi by 2 is 0. So here it is 0. R3 sin theta 3. So R3 is 1 and sin pi by 2. Sin pi by 2 is also 1 and here it is 1. So its determinant is supposed to be 0. And now I am interchanging this row and column, and you know that it will just be minus of the original determinant. So but here it is 0, so there is no change. So 0, 0, 0, 1, R square, R cos theta, R sin theta, 1, 1, 1, 0, 1. Sorry, here it is 1, 0, 1, 1. Its determinant to be 0. For this 0 times everything, so it is be 0. 0 times everything is 0. 0 times everything is 0. Plus, minus, plus, minus. So here it will be minus 4. So I am just finding the determinant for that. Is that thing, but again, you know that here it is 0. So I am not writing minus. So only determinant of this thing. So that is R square times 1 times 0. So it is 1 minus 0 times 0. So it is 0. So 1 minus 0 minus R cos theta in bracket 1 times 0 minus 0 times 1. So it is 1 minus 0. Here then plus R sin theta. Then here it is 1 times 0 and 1 times 1. So 0 minus 1, it is equals to 0. So that is R square minus R cos theta minus R sin theta is equals to 0. Is the polar equation of circle passing through given points. Now you are supposed to find out the center and radius. So compare it with your general equation, that is R square 2R G cos theta plus F sin theta plus C is equals to 0. So that implies your G is equals to 1 by 2, F also 1 by 2, C 0. Okay, is here 1 and here we requires 2, so it is 1 by 2 and so on. So now center is G square plus F square minus C, G square plus F square, comma, tan inverse F by G, here it will be square root. So G square plus F square square root, the square root of 1 by 4 plus 1 by 4, comma, tan inverse 1 by 2 by 1 by 2, it is 1. that is pi by 4, and here you are having 1 by 2 plus 1 by 4 plus 1 by 4 is 1 by root 2 pi by 4. Okay, and radius of square plus f square minus c, that is square root of 1 by 4 plus 1 by 4 minus 0, so it is again 1 by root 2. So this is our practical number 10. Last problem, according to what you have to write in journal. On the Moodle course site, you are going to be provided several other problems, and you try similar such problems at your home, and stay at home, stay safe. Thank you.